Good morning, Course 2. It's Mrs. Elliott again. I'm going to be explaining lesson 104 this morning, which is about semicircles, arcs, and sectors. And you need to be on page 724. Page 724. So, if you're looking at the drawings and going, I don't know what to do, you all know how to do this. You just need to have some explanation and you'll understand it. So they're going to be asking you for perimeters of rectangles, and we all know how to do that. To get a perimeter, it's the length plus the length plus the width plus the width, going all the way around the rectangle. Or another way to look at it is the perimeter equals 2 times the length plus 2 times the width. And the other thing they're going to be asking us is going to be area of rectangles. And everybody knows how to do that one too. Area is length times width. That one's easy. We're not as familiar, but we've all done it. They're going to ask us for the circumference of circles. And we know that the formula for that is circumference equals pi times the diameter, or circumference equals 2 pi radius. 2 times pi times the radius. So those are our two formulas there. They also are going to be asking us for the area of a circle. And that is the area equals pi times the radius squared. Now, actually, in this lesson, they're talking about semicircles. And a semicircle is a half circle. Semicircle is a half circle. That means if we are figuring out the circumference, we're going to have a circumference divided by 2. That's half the circumference. If we're looking for area, it's going to be pi r squared divided by 2, or area divided by 2. Now let's start with example 1. They give us a drawing, and it's actually 2 pieces. We're going to separate into 2 pieces anyway. This is what our drawing looks like, sort of. The dimensions are in meters, so I'm just going to put my M right there. They only give us 2 dimensions. They give us the dimensions of a radius, which we can use. They give us the dimension of this side of the rectangle as 4 meters. But now we have to interpret and figure out what is the long side. So looking at our semicircle, the radius is 5 centimeters, or 5 meters, and we know that a radius is the same at every point in a circle. So if I were to draw in this radius right here, it would be 5 meters. And if I were to draw in this radius right here, it's also 5 meters. So now if you go the full length of this, you can have 5 plus 5 tells us that this side of the rectangle is 10 meters long. Now when we're figuring out perimeter of a figure like this, we are not going to count the internal structures inside, because the perimeter is only going to account for around the half circle and around the rectangle. This dotted line will not be part of the perimeter. So if we use our formulas from up here, they ask us for the perimeter of the figure. The perimeter is going to be 4 meters plus 10 meters plus 4 meters plus the circumference of this part of the circle. So we have to figure that one out. So we know circumference is pi times diameter, and our diameter on this is 10 meters. So our circumference is going to be 3.14 times 10. And that's going to give us 31.4 meters for the entire circle. Now, we don't want the entire circle. We only want half of the circle. So we're going to take our circumference and divide it by 2. 2 divides into 3 once, and with 1 carryover. 2 goes into 11 5 times with 1 carryover. Put my decimal point. 2 goes into 14 7 times. So my piece of the length of the semicircle is 15.7 meters. So I have to put that here, 15.7 meters. And when I add all those up straight across, I will have the exact perimeter of the outside of that structure. So 4 plus 4 is 8. 8 plus 10 is 18. 18 plus is, it should be 33.7 meters. And there is my answer. It's 33.7 meters around. Now, example 2 takes the very same structure, though they turned it the other direction. I don't know if that's to confuse you or what, but that's the exact same. And this time they're asking us for the area. So we're going to be using the area formula. The area formula is A equals pi times r squared. So our area of the circle is pi times, and our radius is 5 squared. So our area is going to be 25 times 3.14. So now I'm going to have to do my multiplication over here on the side. 5 times 4 is 20. 5 times 5 is 5 plus 2 is 7. 5 times 3 is 15. 2 times 4 is 8. 2 times 1 is 2. 3 times 2 is 6. We're going to add this together. 15, 8. And I have to move over 2 places. 78.50. But now I'm going to have to, that is for the area for the whole circle. And I'm doing a semicircle, so I'm going to take my 78.5 and divide it by 2. So now 2 goes into 7 3 times with 1 left over. 2 goes into 18 9 times. 2 goes into 5 2 times. So I'm going to have 39.25 as my meters squared, as my area for the semicircle. So that's the semicircle. And then I have to figure out the area of this part of the structure. And that's going to be, my area for the rectangle is 4 meters times 10 meters. And so my area is going to equal 40 meters squared. So now I take the area of the rectangle here plus the area of the semicircle here and add them together. 40.00, because I have 2 places, plus 39.25 meters squared and meters squared. And so the area of this whole piece, drum roll, 79.25 meters squared. And that's how we got there. Okay, now we're going to be doing something, example 3. And they have a nice circle. And there is a piece. Here's my center point. And this is shaded, so I'm going to just scratch it in with my pen. And they give us a measurement from here to here. Notice there's an arrow at the end. Is 300 degrees. And they tell us the length of our radius here is 6 centimeters. So they want us to find the area of the shaded sector of the circle. All right, first question. How many degrees are in a complete circle? A circle is 360 degrees, right? And so we have 300 degrees here, and that tells us that what's left to complete the circle is 60 degrees. If I add 60 and 300, I get 360. Now, that means that this shaded piece, this sector, this is what they call a sector, is 60 degrees out of 360 degrees. So here we have this fraction that we're going to reduce, and I could reduce it by 10, and then I would have 6 over 36, and then I could reduce it by 6, and I'd end up with 1/6. So 60 over 360 boils down to 1/6. So that's the beginning. Now we have to figure out did they want the area? The area. What is the area? Well, area of a circle equals pi r squared. But this part of the sector is only 1/6. So we're going to make the area of this specific circle is pi r squared divided by 1/6. There's our 1 over 6, right? So now, what do we have? We're going to have the area is, now 1 times this number is just going to leave it the same. Pi is 3.14. Our centimeters for the radius is 6 centimeters times 6 centimeters. So now we have the area is going to equal 3.14 times 36 centimeters squared. And I'm going to come over to the side here. 3.14 times 36. 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. 3 times 4 is 12. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. I'm going to add this together. And then come over 2 places. 1, 2. So it should be 113.4. So now when I rewrite this, the area is going to equal 113.04 divided by 6, because I haven't done this portion of the equation yet. So now I'm going to take 113.04 divided by 6. 6 divides into 11 one time. 1 times 6 is 6. When I subtract, I get 5. Bring down the 3. 6 goes into 53 8 times. 8 times 6 is 48. When I subtract, I have 5. Bring down my 0. Put up my decimal point. 6 goes into 50 8 times. 8 times 6 is 48. Subtract, I have 2. Oh, this is going to turn out nice and even. 6 goes into 24. 4 times 6 is 24. And we made it. So now, what I have here, the area is going to equal 18.84 centimeters squared. And that is correct. Okay, looking on page 762, an arc is a part of a circumference of a circle. So if you look on that circle, it says the following figure, we see two arcs between point A and point B. An arc, the arc from A clockwise to B is called a minor arc because it is less than a semicircle. Refer to this arc as AB, abbreviated. Okay, they're saying it's AB, but you abbreviate it with an arc over. It's not a straight line, it's an arc. The arc from A counterclockwise to B. Okay, so let's draw a circle. Here's our circle. There's A, B, and C. What they're trying to say is, if I travel from here to here, that's an arc, and that's the minor arc because it's the smallest arc. And we would write it like this, arc AB. If I were still trying to get to B, but I go the opposite direction, I would start here, and I would go this direction around to B. This is the major arc. And the way you would have to write this one, because you have to denote that that's what it is, would be A, because we start at A, C, because we're coming around C, B. And then you would also put your arc over it. So you have to tell which direction to go. If you don't have the third point in there, you go directly from A to B. If you need to go the opposite direction around the circle, you have to put in the C. So it'd be A, C, B. And that would describe the arc. We can measure an arc in degrees. The number of degrees of an arc equals the measure of the central angle of the arc. So if minor arc AB in this figure above measures 120 degrees, then the measure of major arc is going to be 240. So here's my central point. If there is a line from here to here, this is my minor arc. If it equals 120 degrees, that's the distance. That means that from here to here, my major arc is going to be 360 degrees minus 120 degrees. So this would be 240 degrees. So this one, the major arc, equals 240 degrees. All right, let's look at example 4. We have a circle. There is a center point. This is O, and it goes out here to A, and it goes out here to C, and there is a dot out here called D. There are my 3 points that we're interested in. They ask, in this figure, the central angle, AOC, that's a central angle, measures 70 degrees. What is the measure of the major arc? Okay, we know that this part of the angle is 70. A circle, a complete circle all the way around, equals 360 degrees. This portion is taken up by this central angle. So if we subtract 70 degrees from this, we will get 290 degrees. So the major arc is this part right here, coming around this way. So arc A DC, that's the major arc, is going to equal 290 degrees. And that's all there is to that. Okay, example 5. This time they give us a coordinate graph. Remember, there's always arrows at the end of each coordinate line. And they have drawn in an arc from 2 to 2. And they say the minor arc with a radius of 2 centered at the origin is drawn from the positive x-axis to the positive y-axis. What is the length of the arc? Okay, what they told us is if we went ahead and did our circle, oh, that's a terrible circle, but if we did our circle all the way around, it would be a circle. So the question is really, what is the measurement of this angle right here? And we know from what we've been learning that this angle is perpendicular, so the angle is going to be 90 degrees, so the arc is also going to equal 90 degrees. That is the minor arc. So if they're trying to find, let me see. What is the length of the arc? Oh, they're asking for the perimeter. They're asking for the circumference between here and there. All right, so we know that we have 90 degrees over 360 degrees. And if I reduce that down, it's going to be 1/4, right? 90 and 360, 1/4. So now I would take my circumference formula. Circumference equals pi times the diameter. And I would have to divide it by 4. So my diameter is going to be from here to here is 2, from here to here is 2, so it's 4 units. So my circumference is 3.14 times 4 units divided by 4. Now, if you're watching really carefully, you can see that these 4s are going to cancel out. So actually, my answer is going to equal 3.14 units. All right, we're ready to go and do our practice problems. Our practice set is on page 727. There's A through D, starting at A. Find the measure of this figure, each measure of this figure. Dimensions are in centimeters. Use 3.14 for pi. Okay, first let me draw my picture. They give us some dimensions. All right, and they have the square boxes here for the square corners. And then for the first thing, they want perimeter. For B, they want the area. So we'll start there with those. Okay, we know that this side on the rectangle is going to match this side, so this is going to be a 3. And these are in centimeters. But we're only going to count this portion of the rectangle, but they did not give us this portion. So we have to figure that out and reason it out. They did give us the radius of the circle. which is 3 centimeters. And so if you know intuitively what we do, here is also a radius, so that means this portion is 3 centimeters. And here, this is also a radius, so that's going to be 3 centimeters. So now we have 3 plus 3, which is 6, plus 4. That tells us the long side is going to be 10 centimeters. 3 plus 3 plus the 4. Because from the center point to the outside edge is a radius, which is 3. And from the center point to the other outside edge is also a radius, which is 3. So 3 plus 3 plus 4. All right, so if I'm going to figure out my perimeter, I still need to figure out the circumference of the circle. This is a semicircle. So we know circumference equals pi times diameter. But because it's a semicircle, we're going to divide it by 2. So our circumference is going to equal 3.14 times, the diameter is 3 plus 3, so 6. And then we're going to divide by 2. So I can actually cancel this out first before I do all the multiplication. 2 divides into 6 3 times. And now I can take 3.14 multiplied times 3, 12, 4, 9. Move over 2 places. All right, there is my circumference. All right, so now to get my perimeter, I'm going to have a 3 plus 10 plus 3 plus the 4 plus 9.42. And I got it way too close. Okay, so 3 and 3 is 6, and 4 is 10, plus a 10 is 29, so I've got 29.42 centimeters. And that should be the perimeter of the rectangle and the semicircle. Now they want to know area. So first we have to figure out the area of the rectangle, and that's easy now because we already figured out some other things. So it's going to be 3 times 10, which will equal 30 centimeters squared. So that's the area of the rectangle. We've got that. Now we need the area of the circle. Well, we know area equals pi r squared, but this is a semicircle, so we're going to divide it by 2 when we get our answer. So we've got 3.14 times, let's see, the radius is 3 centimeters squared. So now we have divided by 2. So we've got 3.14 times 9 centimeters squared divided by 2. And so let's see, 3.14 times 9, 36, 9, 12, 28. We count over 2 places, 1, 2. So we've got 28.26 divided by 2, which is going to be 2 divides into 2 once, 2 divides into 8 4 times, my decimal point. 2 goes into 2 once, 2 goes into 6 3 times. And this is centimeters squared. So I go back up here. Here's my perimeter from the rectangle. So that's 30 centimeters squared. Here's my area from the semicircle, 14.13. I add those two together, 3,144. My answer should be 44.13 centimeters squared. Okay. Number C. Describe how to find the area of this 45-degree sector, and we're supposed to leave pi as pi and then find the area. So here's our Here's our little sector. They're telling us this is 45 degrees, and this is 4 centimeters. This is for letter C. Describe how to find the area of this 45-degree sector. All right, the first thing we need to know is a full circle is 360 degrees, right? And what we have here is 45 degrees. So if I divide both these numbers by 9, 9 goes into 45 5 times. 9 goes into 360 40 times. Oh, I can look at it. 5 goes into 5 once. 5 goes into 48. This is my reduced fraction from 45 over 360. It's 1/8 of a circle. They are asking us to find the area. Let's find the area. All right. So area equals, go back to our formula, pi r squared, right? But now it's only 1/8 of the circle, so we're going to divide it by 8. So 3.14 times 4 centimeters squared is going to be 3.14 times 16 centimeters squared. So here's my 3.14 times 16. 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. I add that up. 4, 12, 8, 9, 10, 3, 4, 5. Count over my 2 spaces. 1, 2. So I have 50.24 for the top. So it's 50.24 divided by 8. And I can't do that in my head, so we're going to have to do it the hard way. 8 goes into 56 times. 6 times 8 is 48. Subtract and get 2. 8 goes into 22 2 times. 2 times 8 is 16. We subtract that and we get 6. Bring down the 4. I forgot my decimal point right there. 8 goes into 64 8 times. 8 times 8 is 64. I'm done with my division. So my area should be 6.28 centimeters squared. There's my answer to C. 6.28 centimeters squared. Now the last thing they ask us to do is to find the perimeter. We still have the same little sector. It's 45 degrees. This is 4 centimeters. Find the perimeter of the figure in problem C. Include the arc and 2 segments. All right. So if this radius is 4 centimeters, this radius is also 4 centimeters. So we figured out 45 over 360 degrees equals 1/8, right? And so what we're going to do with this is the circumference equals pi times the diameter. So our circumference is equal to 3.14 times, well, if this is a radius, 4 centimeters, then the diameter is 2 times the radius, so 8 centimeters. Now we have 8 times 4 is 32. 8 times 1 is 8, 9, 10, 11, carry my 1. 8 times 3 is 24, plus 1 is 25. Move my decimal point over 2 places. Centimeters. So now I have 25.12 centimeters, but we only have 1/8 of the circle. So we're going to divide this by 8. So now we have 25.12 centimeters divided by 8. 8 goes to 25 3 times. 3 times 8 is 24. Subtract, bring down my 1. 8, there's my decimal point. 8 goes in 1. 1 times 8 is 8, and we will have 3 left over. Bring down my 2. 8 goes into 32 4 times. 4 times 8 is 32. And there's my answer, 3.14 centimeters. So that is how we figured it out. Include they want the perimeter of the figure. Okay, that's the perimeter of the arc. So we have 4 centimeters plus 4 centimeters, because that's each of the sides, plus the arc, which was 3.14 centimeters. These should be zeros, right? 4, 1, 8, and 3 is 11. So it should be 11.14 centimeters is your perimeter. And that's how you got there. Okay, good luck. Work hard on your assignment. We'll see you on lesson 105.